So remember, yesterday we talked about the direct proportion, and when two things are directly proportional, when one goes up, the other goes up. When one goes down, the other one also goes down. Whatever the one quantity does, the other quantity also. But today we're going to start off talking about inverse proportion or inverse variation. And when they're inversely proportional, they do the opposite thing. Whatever one does, the other quantity does the opposite of that. And we were talking yesterday about Boyle's law and Charles' law from chemistry. One of those other laws has to do with volume and pressure. If I have a sample of a substance, if I increase the pressure, I'm going to be pushing harder on it. What's going to happen to the volume? I'm going to be squeezing it tighter. The volume is going to get smaller, isn't it? So that's an example of an inverse variation. If I increase temperature, volume is going to go down. Well, with an inverse proportion, it's just like yesterday's, except the formula looks a little different. But you solve it the same way. So look here, you look for the phrase inversely proportional, so I know it's going to be this. That's the inverse equation. And I like to write down the values first. So it says y is 6 when x is 5. Find x. I don't know what x is. Find x when y is 12. So all we're going to have to do is plug those values in. x1 is 5. y1 is 6. I don't know x2. And y2 is 12. So from there, you could work that out, right? Multiply these together. 30 equals 12x2. Divide by 12, divide by 12. What do you get for x2? I think that's 2.5. Isn't it? Yeah. And remember, this is an inverse proportion. If one goes down, the other goes up. They do the opposite. Well, look here. What's happening to the y value? Up or down? It's going up. So what should happen to the x?
Down.
It goes down. So we know that we're sort of in the right ballpark. Fairly simple, right? Just plug it in. But now we have something where it varies jointly. Varies jointly, there are 3 variables. Well, sort of. Instead of just x and y, when you have a joint variation, now you have 3 things, x, y, and z. And unfortunately, there's no easy one-step problem. When you work out a joint variation problem, you've got this k value here. K is called a constant of proportionality. And you have to figure out what the k is in order to solve the problem. So watch over here. And on top of that, you have to read. Because it says z varies jointly. You have to have the k. Z varies jointly with x and the square root of y. It varies jointly with x and the square root of y. And by the way, whatever one comes first, since z came first, that's the one that goes over there on this side by itself. So now I'm going to have x1, y1, z1. And I'm going to have x2, y2, z2. Fill in what we know. It says z is 6 when x is 3 and y is 16. Z is 6 when x is 3 and y is 16. Keep going. It says find z when x is 7 and y is 4. When x is 7, y is 4. So you're going to have to do this in 2 parts. You're going to have to do it in 2 parts. Two parts. Start with this and plug it in. What's z? I don't know what k is. It doesn't even mention k in the problem. What is x? And square root of y is 16. And you're going to solve that for k. We need to figure out what k is. So I get 6k, 3, square root of 16 is 4. Multiply. K times 12. How do you finish it up? Divide by 12, divide by 12. What do you get for k? 1/2 or 0.5? We're halfway there. Because remember, we're supposed to be finding what is z. Well, you can't find z until you find this k value. We're going to take that k value and plug it back in here. Take that k value. Oops, not that k value. Z equals k x square root of y. But guess what? We already know what k is, don't we? So plug it in here. We just found out that k was 1/2. K is 1/2. And now we can plug in the second bit of information to find out what z is. It says find z when x is 7 and y is 4. What is square root of 4? So 1/2 times 7 times 2 is square root of 4. If I were you, here's how I would do that. Don't get out the calculator. What's half of 2? 1. And 1 times 7 is 7. So z equals 7. Does that make sense? So for these, when it's jointly, unfortunately, you have 2 things you're going to have to work out. The first time you're going to work it out and figure out what the k value is. They should give you all the letters x, y, and z. Plug them in and get k. And then once you have the k, you plug that into the equation along with the other 2 letters that you know to get the one you're looking for. Does that make sense? Does that make sense? Chloe, does that make sense? Anybody with questions so far? Oh, because this next one, you're going to be so excited. She's going to be so excited. Wow, you're going to be so excited. Settle down now, settle down. I don't have to be sending you to the hall. You too, Cole, settle down. I think he's asleep. So look at this one. Oh, you're going to get excited. The electrical resistance varies directly with the length. Hey, that's what we did yesterday. It varies directly with the length. But look at this. It also varies inversely with the square of the diameter. How can you have both in one problem? How can you have both? Well, you can't use those down there. You have to write yourself your own equation. Do you see this? It's not going to be a z in there. It's going to be some other quantity. But when you write your own equation, anything that it varies directly with goes on top of the equation. And anything that it varies inversely with goes on the bottom. Did you catch that? I'll say it again for the daydreamers. Anything that it varies directly with will go on top. Anything that it varies inversely with will go on the bottom. So read this problem here. It says electrical resistance of a wire. That comes first, so it goes over here. Electrical resistance varies directly with length. It varies directly with the length. Where does it go if it's varying directly? On top. So it varies directly with the length, that goes on top. And you always have to have the K in there. Keep going, it says it varies inversely with the square of the diameter. So first of all, it varies inversely. That means it's going to go in the bottom. It varies inversely with the square of the diameter. So there's your basic equation. Now we can resistance 1, length 1, diameter 1, and we can do resistance 2, length 2, diameter 2, and fill those in. Well, read this. 100 meters of a wire. What does that tell you? Length, right? 100 meters of a wire with diameter of 6 millimeters has a resistance of 12 ohms. So just fill it in. Then keep reading. 80 meters of a second wire, 80 meters of a second wire, and it says it's made of the same substance, has a resistance of 15 ohms. And we want to know, find the diameter of the second wire. So just like the one we did over here with the two parts, you're going to have to plug in. You're going to have to plug in, find the K, put the K value in, and then work the problem again. So let's do that. We're going to have to plug in. Plug in the first set of information right here. So resistance is 12. I don't know K. What's the length? 100 over D squared. D is 6, and you have to square that. So 12 equals K times 100 over 36. How would I solve that? Did you say cross multiply?
Can they be different
Materials?
different millimeters?
No, they have to be the same units. Good question again. Like yesterday's, those have to be the same units. If they're different units, you have to change them and make them the same. Right. How would you solve this? I think I'm going to cross multiply. This way I get K times 100 equals this way. Don't tell me. It's 360 plus 72 more. I think that's 432. Is someone going to double check me? Divide by 100. It is right? So I get a K value of, it seems kind of weird, but I'm pretty sure it's right. K is 4.32. So remember from over there, once you get the K, you have to plug it back into your equation right here, right? So if my equation is R equals K L over D squared, I just figured out that K was 4.32. Now we should be able to plug in the rest of this stuff, the rest of this stuff, the rest of this stuff, the rest of that stuff. We can still see it. So I know resistance is 15. I know resistance is 15. 4.32. Do I know L? Yes, it's 80 over D squared. How are we going to solve that? I think I'm going to put a 1 under that and cross multiply again. This way, I get 15D squared equals, oh boy, 0, 1, 6, carry the 1, 24, and one more is 2, 5, carry the 2. I think I get this. Move it over 2 places. Is that right? Someone checking me? It's getting late. I'm not at my mental best, it's right. So if I'm solving for D, now I have to get rid of the 15. Don't tell me. We'll see. I get D squared equals, that goes in there twice with 4 left over. That goes in there 3 times, and none goes into 64. Good? Now I have to square root it to get rid of the square. Square root, diameter equals 4, I don't know what. 4 point, what? 8. 4.8 what? It's diameter, millimeters, right? Diameter looks like it's in millimeters. So 4.8 millimeters. There's your diameter. Make sense? Does that make sense? Does that make sense? Do you have questions? That's all I have to say. That's all I have to say today. Anybody with questions? Are there any questions? Does anyone have a question? I'm on 360. And 361. I got WE 1 to 10. And then I have some probs. I got lots of probs. 1 to 4. 1 to 4. 1 to 4. That's it.
Can I grab my book?
Yep. Yeah, I'm way off today, Bow.